I want to do a couple of examples of hypothesis tests for a population proportion. And normally I'd go into a lengthy math major discussion about this, but I'm going to stick to an example and just what you need to know to do the homework. So here's an example with alpha equals 0.05. Test the claim that less than 25% of people have seen a UFO if 237 of 993 have. Okay, so there are three parts to setting up a hypothesis test. Number one is what I'll call the setup. Number two is what you have to do on the calculator. And number three is what I would call the conclusion. For the setup, which we'll start this with, number one, the setup, I'm going to use a chart that I posted in Canvas called the Hypothesis Testing Setup. And the first thing to look at are the words in the claim. Now in this claim, it asks, test the claim that less than 25% of people have seen a UFO. So I'm going to look at the row that's labeled less than to set this thing up. So the claim is P is less than. So I'm going to go the claim, P is less than, and then the percent in the question is 25%, which we're going to write as 0.25. Now looking at the chart again, I'm just going to go read across this column to put the elements of the setup in. So the opposite of the claim is P is greater than or equal. So this goes under the opposite. P greater than or equal to 0.25. And then looking along this row again, H null, which is what they call the null hypothesis, P is equal. H null, P is equal to 0.25. And notice for later on the conclusion, we want to know whether this is from the original claim or not from the original claim. This says not from original. Not original. And then the last element of the setup is what's called H1, or the alternate hypothesis. On this row it says P is less than, and it's a left tail test, as they say. H1, P is less than 0.25. Because the arrow is pointing towards the left, it's what they call a left tail test. And that concludes the setup of this problem. Then number two is what we have to go on the calculator. Let's see, I'm going to make a note of the 0.25, and it's 237 of 993 before I erase this on this other board, because I'm going to need that for the calculator. So,
stop laughing.
On the calculator, I'm going to go to Stat, Tests, and I'm going to arrow down to one prop Z test. And what I have to enter here, the P null, which is the p-value from the null hypothesis, is 0.25. The x and the n are from the sample data. It's 237 people who saw a UFO, and the total sample is 993. And then This prop thing, on this one, you want to match the form of the alternate hypothesis. In our example, the alternate hypothesis is p is less than 0.25. So notice as you arrow across, there are three possibilities. The one that we want for this one is less than p null. Hit enter so it takes, and then hit the calculate button. And when the magic button is hit, it gives out some values. Now there's two of these things on here that we are going to use for answering the homework questions. The first thing is the z value, which is negative 0.824. I'll round it off to, I'll just write 3 decimal places, negative 0.824. And the all-important p value, which again I'll round off to 3 decimal places, is 0.205. P equals 0.205. This z value is what they call the test statistic. And we are not going to use the test statistic, but in the homework they're going to ask you for the test statistic, so you should know what that is. And this p equals 0.205 is what's called the all-important p-value. Roughly speaking, the p-value measures the probability of obtaining the sample data if the null hypothesis is true. Normally I go into a lengthy discussion about that, but I'm going to cut to the chase here. Once we get the information from the calculator, we can draw our conclusion. And the conclusion is based on two things. And this is where, in the beginning of the question, there was that alpha equals 0.05 in the beginning of the question, which I haven't mentioned at all yet. Recall, alpha equals 0.05 is called what they call the significance of the test. Significance of the test. And we are going to compare that alpha value with the all-important p-value. So in this case, so the principle is if p is less than alpha, then we reject the null hypothesis. If p is greater than or equal to alpha, then we fail to reject H null. Now, in this example, P was 0.205, alpha is 0.05, so P is greater than alpha. So since P is greater than or equal to alpha, that means that we fail to reject H null. And now we go back to the setup where we noted whether the null hypothesis was from the original claim or not from the original claim. In our original setup, our null hypothesis was not from the original claim. Original hypothesis not from original. So we fail to reject H null, which was not from the original claim, and this allows us to make our final conclusion. And I have another chart that I posted in Canvas that you should have handy, and this is called the hypothesis testing conclusion wording. And there are 4 entries here. So in this example, we fail to reject not from original. So I'm going to look in the row here that says fail to reject, and I'm going to look in the column that says not from original. So fail to reject, not from original. And this is the wording for the conclusion. There is not sufficient evidence to support the claim. So that's my final answer. So my conclusion is not sufficient evidence to support the claim. Okay, I want to do one more example. Sorry that this is long, but this is sort of a complicated subject. But I'm going to do one more example of this. And this one I'm going to try to cut to the chase even a little bit more than I just did, just cutting it down to the essentials. So here's another example. In this example, test the claim with alpha equals 0.05 that at least 60% of people saw a UFO. I don't know why I'm focused on this UFO business. If 586 of 1,038 saw one. Again, I'm going to cut to the chase here. So for the setup, notice that in the question it says at least 60%. And so I'm going to look at my setup chart. I'm going to look at the row that says at least, and it says the claim is P is greater than or equal is the original claim. The claim P is greater than or equal, and the 60% I'm going to write as a decimal 0.6. The opposite is P is less than 0.6. P is less than 0.6. The null hypothesis, P is equal to 0.6, and now this is from the original claim. H null, P is equal to 0.6. This is from the original claim. And the alternate hypothesis, H1, P is less than 0.6. And again, this is a left tail test. So there's the setup. And now I'm going to go to the calculator. On the calculator, I'm going to, again, stat tests, one prop z test, and now the p null, the p value from the null hypothesis is 0.6. The x and the n are the 586 out of 1038. 586 out of 1038. I'm going to match the form of the alternate hypothesis for this one. Notice there's 3 possibilities. There they all are. I'm going to hit enter when I get to the one that I want. Calculate. And this time I get, for the test statistic, z negative 2.33 and the p-value of 0.009. I'm truncating. The important thing is whether it's greater or less than or alpha. So in the homework, they're going to ask you for this z value. This is what they call the test statistic. In this example, with the p equal 0.009, the significance of the test 0.05, in this case, the p is less than alpha. P is less than alpha. That means that we reject H null. The H null was from the original claim in the setup, from original. And now I can look at my conclusion chart, look at the part that corresponds to reject H null from original claim. Reject H null is the first row, from original claim is the first column. There is sufficient evidence to reject the claim, and that's my conclusion. Sufficient evidence to reject the claim. And if you want to write out the claim, that's okay. I'm usually too lazy to do that.